Alright, ladies and gents, welcome to the next section. This is the next unit, Unit 6. 6.3, in fact, separation of variables. We're going to separate variables to solve simple differentiable equations. We did this last year in AB. This is like section 10.4. This was one of those ones that was like a 6-point question or a 5-point question on the AP exam. You're going to have another one like this as well on the AP exam, so please make sure you kind of go through this section and make sure you know how to do it. So every day, physical phenomena can be represented and described by differential equations. For example, population growth, sales predictions, especially Newton's law of cooling. If you were with me in Algebra 2 Honors, we definitely did one of those problems when we got to logarithms in Algebra 2 Honors in Unit 7, I think. A function is a solution of a differential equation if the differential equation is satisfied by substituting the solution into the equation. So for instance, if we say that y equals e to the negative 2x is a solution to this equation, okay, how does this actually work? Well, since y is e to the negative 2x, I can plug that in right there. But then it says y prime. So if I took the derivative of this, I would get negative 2 e to the negative 2x. Now if I sub this into y prime, sub that into y and solve, so negative 2e to the negative 2x plus 2e to the negative 2x equals 0. Well, yeah, that's true because that's equals 0, so 0 is equal to 0. So it needs to solve the differential equation. Okay, so every solution that I get needs to solve it. So let's kind of get moving. So y is equal to c times e to the negative 2x is what we call the general solution. Because it has an arbitrary constant, yet it still solves the differential equation. And then solutions to differential equations may not be unique. So you might have 15 differential equations, and when you're solving them, 3 of them might be the same. And that's okay. All right, they don't have to be unique. So how do we solve differential equations? Well, we solve them using what we call separation of variables. In order to solve, we separate the variables to both sides and equal sign integrate. Okay, so let's go through an example here. So this is y prime equals 2x over y. Well, y prime is also written as dx over, not dx over dy, dy over dx. That's better. dy over dx. So what I want to do is I want to put all of the x's and dx's on one side, put all of the y's and dy's on the other side. So this is the same as y dy equals 2x dx. Okay, cross multiplied, got rid of, moved your x's and so on. You can figure that out. You probably remember a little bit of this from last year. Then what I want to do is I want to integrate both sides. So integrate. When I integrate this side, I get y squared over 2, right? Equals, when I integrate this, I just get x squared. Okay? But remember that you're technically going to get plus c, but it's not necessary to put plus c on both sides. So I'm going to just put plus c over here. Because these are indefinite integrals, you have to have a plus c. I'm always going to put it just on the x side. All right, and then what I do is I just solve for y. And so I get y squared equals 2x squared plus 2c. But this 2c is still a constant, right? So I don't really need that 2c. I can just leave it that way. And then if you actually want to solve it, and you can say, square root both sides, and you can get y is equal to the square root of 2x squared plus c. And that's okay as well. If you wanted to leave it as y squared equals 2x squared plus c, that's fine too. It doesn't make that big of a difference. All right. Let's go to number 2 here. So I want to solve and get rid of stuff here. So I'm going to put x's on one and y's on the other. So I get dy over y equals what looks to be x dx over x squared plus 4. Then, so I separated them. Hopefully I separated them correctly. It looks like I did. I want to integrate. When I integrate this side, if you remember, this should be the ln of y. All right. Hopefully you remember that. Now we can say absolute value. Might as well put the absolute value there because we don't actually know what y is. So let's do absolute value. Equals. This case here, I need to say that u is equal to x squared plus 4. Du is equal to 2x dx, and dx is equal to du over 2x. So this x and this x are going to cancel. Okay, the 1/2 is going to come out front, and this is then the integral of 1 over u du. Well, 1 over u is the another ln of u, right? So this is the ln of the absolute value of y equals 1/2 times the ln of the absolute value of x squared plus 4 plus c. Now, the absolute value of x squared plus 4, I don't actually need absolute value there. That's never going to be negative, so you can get rid of those and put parentheses if you so choose. It's not that necessary, but you can if you want to. All right, now, how do I do this? Well, what I am going to do is kind of convert this a little bit. So if you remember, so this is still the absolute value, or natural log of the absolute value of y. This 1/2 actually goes as an exponent, so this is now the ln of the square root of x squared plus 4 plus some c. Hopefully you can see that the 1/2 is now a power, right? And then that power is to the 1/2, so that means it's a square root. Now I need to get rid of my ln's, so I need to take e and raise it to both sides, and I'm going to get the absolute value of y is equal to, this is going to be kind of crazy, but if we look at it, this is e to the ln of the square root of x squared plus 4 plus c. But because I'm adding something here, I can actually multiply it by e to the c, right? Because I have the same two bases. Technically, it's ln of the square root of x squared plus 4 plus c if I want to get rid of this e. But I don't. I want to split it up. And so then what happens? Well, e to the c is just one big giant constant. Okay? It's just one big giant constant. Right? E is a number, c is a number, it's still a number. Okay? And so now let's finish it out here. Let's go a little further. So I have this, and absolute value of y is equal to this. Well then, I have the absolute value of y. This piece here is just going to be the square root of x squared plus 4 times c. Okay? Hopefully we remember that and kind of how that works, natural log rules. And so then I want to get rid of the absolute value. So absolute value is equal to, when I do this, you got to think you need a plus of this times the square root of x squared plus 4. And then because it's absolute value, you could also be negative of that as well. Okay? And then because this is your answer, more often than not, based on what the other work is you're going to have, this is also going to be positive square root, positive c square root of x squared plus 4. And the reason why is because c is still a number. So plus a number minus a number, this is still a number. Okay, this is still a number. So, well, I don't know why I did that. I should have just done c. So this is still a big C here, and so that's why I can do that. Okay, so that's for separation of variables. Fantastic. Let's go to some other problems. Now I want to find a particular solution given that initial condition of y of 0 is equal to 1. So I know that all of this garbage here is equal to 0. And I want to put x's on one side, y's on the other side, and go from there. So the y squared minus 1 I'm going to leave here. I am going to bring over this xy dx over here. So I'm going to rewrite it as this. I'm going to get e to the negative x squared times y squared minus 1 dy equals, I'm going to bring xy dx over, so negative xy dx. All right, now I have everything good. What do I want to do now? I want to basically divide by this, bring it over by dividing, but then I want to divide by this y and bring it over. Okay, so I'm going to get y squared minus 1 over y dy equals, what does this equal? This equals negative x over e to the negative x squared dx. Okay, now I want to integrate both sides. When I integrate both sides, I'm going to take this piece here and I'm going to split it. So it's y squared over y integral dy minus the integral 1 over y dy equals, All right, and then working on the right side here, you can see that if I have e to the negative x squared, I want to make that positive, so it's going to pop up. So really it's the integral of negative x e to the x squared dx. Okay. Hopefully we can see why that becomes that. And then the negative is going to pop out. Okay. I'm going to make u my x squared, du my 2x dx, and dx is equal to du over 2x. Again, the x's are going to cancel. The negative 1/2 is going to pop out, times the integral of just e to the u du. So now let's fix and how to do this. So this becomes just a y. So that's just y squared over 2. This is 1 over y, so that's the ln of the the ln of the absolute value of y, equals negative 1/2 just e to the u, but u in this case is x squared, so e to the x squared. Again, plus some value of c. Okay, so that's my integration. Now what I want to do is I know that y of 0 is equal to 1, right? That's what it told me from the beginning. So I'm going to plug in the values of everything else. So x is 0, y is 1, so let's plug it in. So I get 1/2 minus the ln of 1 equals negative 1/2 e to the 0 squared plus some c. This is basically allowing us to find the value of c. All right, so that's what I want to do. So now let's go up here a little bit. So 1/2 minus the ln of 1 is 0, so I don't need to write that. Okay, so I'll leave the 1/2 there. And then e to the 0 squared, so that's e to the 0, so that's just 1. I'm going to bring the 1/2 over, so that's equal to c, so c is equal to 1/4. I'm kidding, I can't do math. I was multiplying. C is equal to 1. Okay, c is equal to 1. And so now I want to solve the equation, okay? And basically you're going to take this piece here and you're going to plug in c. All right, so I get y squared over 2 minus ln of the absolute value of y equals negative 1/2 e to the x squared plus 1. And there you go. Now, most of the time we want to try to solve for y, but because y is kind of crazy here, we're not going to be able to easily, so that's okay to leave it that way. All right, don't get too bogged down with trying to solve for y. If we can't easily, then we're going to, but in this case we can't. Last one. Find a particular solution curve. Find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point x, comma y. So because it has a slope of y over x squared, that means we know that dy over dx is, not dy over d, oh my gosh, dx dy over dx. Is that what I had at the beginning? Or dy? I don't know. I don't remember now. Y over x squared. Because this is the slope, that's equal to dy over dx. Let's solve for our x's, or equal, put x's on one side, y's on the other, right? So I get dy over y is equal to dx over x squared. Another way I can write this is the integral 1 over y dy is equal to the integral of x to the negative 2 dx. Let's integrate. This is the ln of the absolute value of y equals, this is x to the negative 1 over negative 1, so that makes it negative, plus some value of c. Okay. Now, what I want to do is I want to solve for c. No, I'm kidding. Solve for y, because this one's easier. We can solve for y in this case. All right. We can definitely solve for y, but let's see here. How do I want to do this? I don't actually have to solve for c yet. I'm sorry, back that up. I don't have to solve for y yet. I can, but I can plug in 1 and 3 right now into x and y to see what I get and find out what the value of c is. Okay, so let's do that. So this is the ln of 3. That might not work too nicely, will it? It might not work too nicely. Well, it might. So let's find out. And this is negative x to the negative 1 plus c Oh, it's negative 1 to the negative 1, which is just 1, right? So that's just equal to negative 1 plus c. This is not going to work out nicely. So we're going to have to solve. Oof, that stinks. If we had better numbers, we would not have to solve for y first. But in this case, it's going to make it easier if we solve for y, because, I'll show you, because right here, I can take e and raise it to both sides. So that's e to the ln of the absolute value of y equals e to the negative x to the negative 1 plus c, but really it's times e to the c, which we know that this is just a big old c as well, okay, because that's just a constant, right? And so this is going to cancel, so this just leaves the absolute value of y equals e, or equals c times e to the negative 1 over x. I just put the x to the negative 1 in my denominator, but that's the same, that's okay. Alright, so let's now, I guess, yeah, let's plug in my x's and y's now. It makes it easier. Because e to the negative 1, yeah, that's going to make it a lot easier, right? So this, we're going to bring this up here. So I get absolute value of 3 equals c times e to the negative 1, which is this is just 3 equals c, and this is 1 over e. But now when I solve this, I get c is equal to 3e. Okay? C is equal to 3e. I guess I could have done it with the other one, like plugging in right here. Plugging in like right here, but I don't know if that was going to work out really nicely. It might have. I bet you it probably would have, because I would have had to done e anyway. But it's kind of trial and error a little bit. So now I want to solve for y. Absolute value of y is equal to 3e, that's the c, times e to the negative 1 over x. Alright. So then, really, you get the plus or minus in front, but that's okay. So really, it's just y is equal to 3e times e to the negative 1 over x. If you want to clean this up even more, okay, if you want to like really clean it up, this e and that e, what's going to happen is the e is going to stay there. It's negative 1 over x, just plus 1. Okay, if you really want to clean it up, you don't have to. You can leave it like that. That's okay. But for the most part, that's it. It kind of stinks, this one, where you weren't sure if you could just plug in x and y right now and then solve for c. It would have been a little hard to do that, so you had to do e to both sides and then manipulate it from there. Hopefully they don't get like that, but I guess they could, but now you know how to do it. So I'll see you in the next one. Deuces.